In this video, we have to discuss the Laplace transform of some other signals. Those signals are exponential function and one property. I will explain one property also, right? So first of all, I am taking here the given function x of t function. X of t is e to the power of minus at into u of t. X of t is e to the power of minus at into u of t. That means this signal is exponentially decaying function. This exponential decay function is defined from 0 to infinity because this complete signal is multiplied with u of t. U of t always explains the time limits from 0 to infinity. So first of all, here I want to draw the graphical representation of the given signal with respect to time axis. This side is negative axis. Now this given signal multiplies with u of t. So if it is multiplied with u of t, that signal is defined from 0 to infinity. We have to take only these limits. Don't write these limits. So within these limits, what is the function? 0. Function is not defined. This is 0. Now substitute here initial value and final value, right? So I am substituting here t is equal to 0 in this. E to the power of 0 becomes 1. So it starts from here. And substitute infinity here. E to the power of minus infinity. E to the power of minus infinity becomes 0. So here it becomes e to the power of 0 and here it gives e to the power of minus infinity. That value is 0. So exponentially decaying function. Right? This is exponential signal decaying function e to the power of minus at with respect to time axis. Now we have to find out the Laplace transform of the given signal. So Laplace transform of x of t is x of s. That is, I am writing like this, Laplace transform of e to the power of minus at into u of t. So whenever this time domain function multiplies with u of t, directly apply unilateral Laplace transform or write the Laplace transform function limits are from 0 to infinity because the function is defined only positive time axis side. This side it is not defined, right? So within this time period, what is the function here? Exponential function e to the power of minus at into e to the power of minus st dt. E to the power of minus at into e to the power of minus st dt. So bases are equal, then power should be added. Then the signal becomes here, integration from 0 to infinity, e to the power of, powers are added, minus t into s plus a with respect to t. Right? So then apply integration operation. Integral of e to the power of ax is e to the power of ax by a. So from that, directly I am writing now equation e to the power of minus t into s plus a by minus of s plus a, limits or changes from 0 to infinity. Then substitute higher limit and lower limit. So higher limit is substituted, it becomes e to the power of minus infinity minus lower limit is substituted in this e to the power of 0 by minus of s plus a. So e to the power of minus infinity is 0 and e to the power of 0 is 1, minus minus get cancels, then directly which becomes here 1 by s plus a. So the standard formula is Laplace transform of e to the power of minus at into u of t is 1 by s plus a. Laplace transform of e to the power of minus at into u of t is 1 by s plus a. Time domain is converted into frequency domain. The time domain function is defined from 0 to infinity. That is explained by this u of t representation. So u of t, unit step function. So this function is defined from time is from 0 to infinity, right? So time limits of the time domain signal is explained by this one, and later we are converting this time domain function into frequency domain, and in frequency domain the signal is now 1 by s plus a is there, 1 by s plus a. Now we have to write the frequency domain limits of the frequency domain representation. So limits of the frequency domain representation is explained by another standard term, that is region of convergency, ROC. ROC explains the region of convergency. ROC explains the limits of the frequency domain representation. So the main aim of ROC is which gives the limits of frequency domain representation. Right? So to find the limits of the frequency domain representation, ROC term is used, region of convergency. Then to find the ROC, again we want this expression here. So in this expression it has two parameters are there, one is numerator and another is denominator. ROC always we have to write from the denominator. That means denominator factors are called poles. So ROC is defined from the poles, right? So ROC defined from poles, but it does not consist poles. So ROC does not consist poles, but that is defined from poles here. Means the starting point, where the starting point and ending point is explained from the poles, but within the ROC poles are not defined, right? So for that purpose, here I am taking denominator of this one. Denominator of this one is here S plus A. Then immediately we have to assume greater than the 0 or less than the 0. That means ROC is defined either left side of the S-plane, left side, or right side of the S-plane, right? So ROC is defined either one side, either left side or right side. Sometimes it is defined in finite limits also. That is depends on the time domain function. If the time domain function is defined only positive time axis side, then immediately we have to take ROC is whatever the denominator part here. This denominator part is we have to assume with greater than the 0 representation, right? And if the given function is defined left side, suppose here I am writing like this. Whenever u of t is given, time domain function multiplies with u of t, then immediately we have to take here greater than the 0. The denominator should be greater than the 0. If the time domain function is defined with u of minus t, then we have to assume here less than the 0. From that, we have to draw the ROC representation. See, now here I am taking here u of t is u of t with greater than the 0, u of minus t is less than the 0. According to the given signal here, the signal is multiplied with which function? U of t. U of t means the complete signal is defined only positive time axis side. Then we have to take this denominator is defined greater than the 0. So 1 by S plus A is there. I am assuming like this, S plus A is greater than the 0. S plus A is greater than the 0. S plus A is greater than the 0. ROC is nothing but here the S domain representation. That's why we have to write here S. S is nothing but ROC. So S is greater than the minus A. From this we have to find only S value. Then send this A is right side this side. Then it becomes minus A. So S is greater than the minus A. ROC is defined greater than the minus A. That part we have to draw like this. So to draw the ROC, first of all we have to draw S-plane. S-plane is this explains the real axis and this is imaginary axis, right? So combination of real and imaginary is nothing but S-plane. And now we have to take that ROC greater than the minus A. Negative real value is there. So this side explains the negative real. So just I am assuming one A value, negative value is defined this side. So minus A. So pole is indicated here. Denominator factors are called pole. So one pole is indicated. Then immediately we have to draw ROC. So ROC always here parallel to the imaginary axis. In S-plane, ROC is parallel to imaginary axis. Right? So here this ROC is parallel to imaginary axis. Imaginary axis defined like this. Now we have to draw one line parallel to the imaginary axis exactly here, because ROC explains it greater than the minus A. So the representation draw like this. So draw one line without this pole, because ROC does not consist poles. So without that pole, draw one line parallel to the imaginary axis exactly at minus a. Then greater than the minus a means this side, completely this side. So we have to shade this area here. The shaded area explains the ROC, right? So ROC is defined completely greater than the minus a. For every signal we have to draw the ROC because ROC is used to find the stability analysis, whether the signal or whether the system is stable or unstable. That is explained by ROC representation. So for few functions we have to draw the ROC also, right? Now finally here I have explained one simple problem that is like this: Laplace transform of e to the power of minus at into u of t is 1 by s plus a. See, here exponential power minus symbol is there, then immediately it gives the plus symbol. So then this gives the ROC is greater than the minus a. And from this directly I am writing one more equation: Laplace transform of e to the power of at into u of t. Now the power of the exponential signal is here, positive power is there, right? So e to the power of at into u of t. Then here positive symbol explains the here minus symbol 1 by s minus a. 1 by here positive becomes here minus. So 1 by s minus a. Then the ROC explains s is greater than the a. ROC is changes because here the complete exponential function is changes here, right? So ROC is greater than the a means draw one S-plane like this. This explains the real axis and imaginary axis. Then indicate one pole. That pole is a here, positive pole. So indicate this side, right side. Then draw one line parallel to the imaginary axis. Then indicate greater than the a. So this explains the ROC. In this case, the ROC is greater than the a is there, but here the ROC is greater than the a. In this case a, and here minus a, greater than the minus a. Both the functions explains the greater than, but positions are changes. One explained from the negative real pole and here positive real pole, right? So these are the basic signals and these are also called as properties of ROC. Properties of ROC, these points. Properties are here ROC defined from the poles, but it does not consist poles, and ROC is defined either left side of the S-plane or right side of the S-plane, and ROC in S-plane ROC is always parallel to the imaginary axis. So these points are comes under properties of ROC, and now onwards we have to write ROC of the given signal also. After converting from time domain to frequency domain, again we have to indicate ROC, right? So please take this now.